Good morning. I would describe myself as being not the only person, but one of the people on the spot for security, as opposed to a noted expert in Windows. The other thing, what I actually do is I manage the server product group, that is the development group for the Windows server family. Security, as is obvious just from reading the press, but as the environment around us to change, is in fact right now the primary focus for the Windows group, as I'll give you more detail on later this morning. Also, I was glad to see you gave Denise a hand when she mentioned the CDs. That was, I think, because you appreciated it. What's should be even more appreciated is how hard it is for her to corral all these presenters that insist on making changes at the last minute, which is the only reason it's so hard for us to have CDs. They just want to do the best for you. So what I'll do this morning, I'll start by talking about the challenges of security to kind of frame the whole talk, the challenges in the industry, not just to the Windows platform. And then I'll talk about the three key elements of our security strategy from the core Secure Windows Initiative, the Strategic Technology Protection Program, which we announced in October, and then Trustworthy Computing, which we recently wrote a paper on and announced, if you will, in a memo from Bill to the company. And then lastly, I'll talk about specifically how Windows.NET Server helps build secure connected infrastructure that's a key element in the Trustworthy Computing framework. So this is, of all the things that I'll talk about today, I hope that you walk away understanding this one thing, that our commitment on security is above everything else we do. It's to do everything possible that we can to enable every customer to be able to work, communicate, and transact securely over the Internet in the fully global and most challenging and at times hostile environment. So there are three sets of challenges around doing that, around secure computing. First is around the products themselves. Oftentimes products lack security features. It turns out the Microsoft products, the Windows products, have built-in security features from day one. And so in a sense, this isn't the biggest issue that we face, but many other platforms are not particularly strong in this area. Products have bugs and vulnerabilities. It turns out this is a challenge that we face as well as other platforms. We're really, as I'll show you later, not particularly better or worse, but we are the most visible by far. So this is an issue that we've focused hugely on. These problems are never solved end to end by technical standards. There are standards for certain elements. We use standards whenever we can. There are standards for authentication, for example, in Kerberos, the distributed authentication protocol that we use. There are standards or external criteria for evaluating systems. We apply those wherever possible as well, but they don't solve the problem end to end. And then lastly, there are going to be vulnerabilities and configuration changes you need to make to keep systems secure, and it's fundamentally too hard to keep systems updated when you have large, diverse, never fully managed environments. There are challenges around process because I think one of the things that we have learned and focused on over the last several years as we have penetrated up and out more into enterprise services built on Windows is that process is such a key part. And customers, we find that customers are not fully prepared to run secure networks in today's environment. They haven't designed their networks for security. The roles and responsibilities, who's an expression we use here, whose butt's on the line to ensure that a network or a service, a piece of a service is totally secure. When something goes wrong, who's the person that's going to clean it up? And if there's any confusion about that, there are gaps, things don't happen, there's conflict, and the net result is that you're not secure. So then something happens, or you're trying to ensure that something didn't happen. Do you have the right process in place to collect the right audit information, ways to process it, ways to follow up and trace down? And we at Microsoft, like everybody else, have lived through real penetration attempts, real serious penetration attempts. on our networks. It happens all the time. Even at home, you hook up one of these firewalls, if you start monitoring. It's amazing what's going on out there. And then when disaster hits, if it does, what's your plan for cleaning up, for shutting down and shutting down the watertight doors in the network, doing restoral of systems, keeping things isolated, making sure that your core business processes keep running. And then lastly, it is evolving. I'll talk later about our Secure Windows initiative. We have a team that has been actually literally working for years, understanding the latest in the evolution of security technology, trying to stay at first not too far behind, and now one step ahead of the collective intellect of people that are hacking and attacking systems today. And then people, you simply can't run a corporate network without people that are adequately qualified, competent, and trained. And the lack of commitment is probably the first barrier. It's quickly broken down after the first serious incident, but leading up to that and leading up to different kinds of unanticipated incidents after that, the commitment to security, the commitment to take the pain, the cost, the limitations necessary to run a very secure environment is often not there. And then people make mistakes. In fact, the technology and the processes have to anticipate that, because people will make mistakes. No surprises here. So at the core of our security strategy is the Secure Windows initiative. It's all about designing and implementing the most secure products at the core. It's the vulnerabilities in the products that you read about. Those are things that we attack with the Secure Windows initiative. The Strategic Technology Protection Program is all about helping customers take the technology we give them and the technology that they use from others and run those in a secure way. It's all about tools helping the customer operate their systems securely. And then the encompassing vision that has the breadth and the farthest reach forward is what we call trustworthy computing. That's what Bill sent a piece of mail to all of Microsoft about just a few weeks ago. So I'll talk about these things in a little more depth now. Secure Windows Initiative, engineering for security is fundamentally what it's about. Our goal is to eliminate every security vulnerability in the product before it ships. This is a comparison of the number of incidents. It was as of September 24th, this last year, 2001. And it shows that the number of vulnerabilities reported in Windows was on par or lower than the other prevalent systems. SCO in this chart's a little bit lower. SCO is not used nearly as widely as any of these other systems. So you can see we're actually we're on par with the industry. But as I said before, we are the most visible and most widely deployed system. It's not good enough. It's not good enough for us. Our commitment is to be the best in this dimension. And the way we attack that, this is a summary of the Secure Windows Initiative. It's a fairly dense slide. I think the important point is that there are many elements of our attack on the vulnerabilities and design issues. And what we are doing is changing the culture. In fact, I would say it's fair to say we have changed the culture of the entire Windows development group and of Microsoft around security to basically say, in the same way you were a great engineer if you could write secure, robust code, reliable code, well-engineered code, it has to be secure. And the way we do that is first we focused on people. We literally have a team called the Secure Windows team. It is in my group. And it's a team that over the last several years, they've had the responsibility to report and deal with vulnerabilities. And that, by the way, was one of the first things we did is we went very visible and public on it. We get information about a vulnerability as soon as we have the fix or workaround prepared, so that we can arm customers to defend against it. Then we disseminate all the information about it widely to fully equip our customers with the tools to deal with it. But so this team, by being the response team, also gained a deep-seated both feeling and understanding for the importance and breadth of the issues. And what they've done is put together training programs to train every, and I'd say developer, but it's really every person involved with products at Microsoft in how to design, build, document, secure products. They had, up until a couple of weeks ago, they had trained a total of about 3,000 people at Microsoft over the last couple of years. And over the last 2 weeks, we basically tripled that in a way that I'll talk about before. But they have built up a course and sort of a way of teaching people and then having them work through reviewing each other's code and such, and then identifying, reporting vulnerabilities, using tools and all the things that are the elements of the process and technology. But they've trained people. So that's at the core of this. We're training our people. And I believe at this point, I believe that we have the most, we have a team of engineers that understand more about designing secure products than any other organization in the world. So process, the key elements of the process that they've educated the people in is fundamentally to make security a critical factor in every product they design. They spend some time up front explaining how that, why that's so critical with lots of direct real-world examples. I myself have introed some of these courses. I spent a lot of time talking to customers after Code Red and NIMDA experience. It's easy for me to describe what happens around some of these vulnerabilities because I have worked closely, visited, talked to, video conference with customers, and I know what they went through. So the key things, cross-group design reviews. I mean, as with any software development process, it's building it back into the engineering up front, but then because developers make mistakes too, and learn from cross-group review, being on both sides of it. A key element of it is the design reviews. Threat analysis, right up front, there's a model we have for analyzing the different kinds of threats that products can be subjected to. And then basically in the review, you say, well, okay, so here's the threats that this kind of product be subjected to, and here's why this product's not going to have that problem in this service or this component. The red team is a special part of the Secure Windows team, and that's a team of people who are particularly experienced, particularly trained, and maybe the best way to say it is particularly gifted at looking at code and finding these kinds of problems. Because we have found that there are people, there's a small number of people who are really skilled at this, who can just look at a piece of code and see these kinds of issues. So they go to it, they do spot checks for these teams to make sure that the results of the training and the review are high quality. We don't worry just about buffer overruns. We've analyzed all the kinds of threats we've seen and the kinds of threats, and then beyond that, the threats we can envision as extensions of those. It's not just about buffer overruns. In fact, there's a book called Writing Secure Code, authored by Michael Howard and David LeBlanc. Michael is in the Secure Windows team. David LeBlanc, interestingly enough, was the guy that worked for Microsoft in the IT department responsible for the security of our whole network. So it's a very pragmatic book, but it covers all these different kinds of threats in how to write secure code, how to build secure network applications, and threat modeling and analysis. And then we have a very tight automatic feedback loop and certain pieces of code sign-off requirements I mentioned here. We're tracking. We track whether every piece of code gets reviewed. We have some pieces of code actually that are core security pieces that the source code control system automatically, if somebody tries to check it in, will stop them unless a particular individual or set of individuals have signed off on that code. So we're very rigorous about protecting the key pieces of code. And then lastly, we do a lot of work with external reviews, utilizing everything, anybody's expertise that we can find to apply to this problem and learn from. And then technology, one of the other things that we've done that I think is very unique, we acquired a technology called Prefix, and our research group actually took it over, and there's now a sort of a runtime version of it. But these tools scan the code. We use these to scan all the code of the .NET server We used it on Windows XP. It doesn't find every problem, but it finds a large number of the different types of buffer overruns and stuff. Bugs are automatically generated and filed in our bug database and back against the developers, and it gets fixed. So there's we use these tools to scan. When we see bugs that aren't caught by these tools, we go back and update the tools. So this is this constant evolution. None of this is a one-time thing. It's very much a change in the way we work. It's a journey for sure. And then the Visual C7 compiler has runtime buffer overrun checking. And then we have a number of different tools specific to different types of domains. Like if you write an RPC-based service, we have a tool that you can run against it as a test tool to find all kinds of to find vulnerabilities that you might have inadvertently put in. External security review. I mentioned we do this. We actually do this in several different ways. We've certified our core crypto providers with the FIPS 140-1 according to the FIPS 140-1 spec, which is a requirement for the government. Common criteria for international governmental certification is in preparation. It's a process that takes years. There's the third party involved in working through and ensuring we have all the information we need to support that. We make fixes or changes as necessary. We've used in a number of different times, number of different ways with companies. We used NAI, for example. We used a number of other companies and engaged them to review certain services in the system. And what we found is that, like I said, some people are particularly gifted at this. Some companies are really good at this. So whenever we see the opportunity, we'll engage consultants to do that, and then if things work out, we'll engage them further in the right kinds of areas. So we use external parties that we pay to help us ensure that we're building the quality products. And then lastly, we've distributed source code to about 80 different agencies, universities, government agencies, labs, and things that are doing work to enhance or understand the security capabilities of Windows. Now, I mentioned that we had trained a lot more developers. What we decided to do was to ramp up our Secure Windows initiative, and we call it the Windows Security Push. We've been doing this for years pretty steadily. That's how we got 3,000 people trained. That's across a bunch of different Microsoft products and a large part of the Windows group. But when we had these incidents last fall, we decided that we just need to ramp it up as fast as possible right now. And that's what we did. We've got the entire Windows team has been trained as of Friday, and that includes, it turns out, it includes everybody except for the administrative assistants, so that we all live, breathe, and think security. The teams are off now. Then they put together plans specifically for their parts of the product to execute the design reviews and run the tools in the right places and do threat modeling and such. So we're going back across the entire .NET and XP code base and doing that. And those fixes, well, obviously it'll be in the .NET server at release time. It'll also be in the Service Pack 1 for XP. And then lastly, we'll take that, and anytime there's common code that back to Windows 2000, there's common code back to NT4, less and less as you go further back. And any of those identified vulnerabilities that we find, we will appropriately backport those and put those into Windows 2000, Service Pack 3, and Service Pack 4. So this is an unprecedented, in my mind, unprecedented commitment to building secure products. And it's, we won't just do this once. It means that now the whole Windows team will operate with a full focus on security going forward. We will, we don't have a formalization around certifying developers that they've been securely trained, but we actually did track every single person to ensure they got trained. and we track every piece of code to make sure it's reviewed. I expect we will have an ongoing recertification process because the Secure Windows team, the things they learn about and the tools and such all evolve. So we'll continue to keep up to date. So let me shift gears a minute. This last summer, actually in August, I started talking to customers that had problems with Code Red. And it became obvious that one of the areas we need to focus on was helping customers around keeping their Windows systems secure. And one other thing I forgot to mention. I said we're going through and looking for vulnerabilities in code. The other thing we're doing in the .NET Server is we're defaulting all the services to be off, and we're configuring we're by default configuring the system to be locked down as possible, and we'll turn services back on. Just as a way to reduce attack surface. It's a security practice that is exactly the right thing to do for the most secure system. The reason that it wasn't locked down before is it can be inconvenient with respect to usability. Everything before was just turned on, or not everything, but many things were turned on so you didn't have to find them, they were just there. But that also increases the attack surface, and this would be true of any product. So Strategic Technology Protection Program is about customers, helping them secure their systems with all the important dimensions of people, process, and technology. So when I spent time talking to these customers and many people on our team did, I'll tell you what, the simple fact was the patches and configuration information to avoid Code Red and NIMDA were out months in advance of the actual attacks happening. Any system that was updated or configured according to recommendations was not impacted. It's that simple. In organizations, that was true where systems, it was proven to be true where systems were updated. You'd see service providers where the systems they managed and deployed services on were all carefully managed and updated, no problems. Then they had systems that were in developers' offices that were totally unmanaged. Those systems would be impacted. Okay, that's just a kind of and it wasn't just service providers. In any environment where they had some systems that were managed better than others, that was the case. But what became obvious when you talk to these customers is that we need to make it easier because it's just a big challenge with the number of systems and the complexity. They didn't know which patches they needed. They didn't know where to find the updates. They didn't know which machines to update. They found machines they didn't even know they had. That were sources of viruses. They found them the hard way. Rogue servers, that's the example. Those you could call developer servers rogue servers, I suppose. But it was clear they needed help. Okay, their process. You could argue that their people in process weren't prepared for this. But in our minds, it needed to be easier for them. We need to supply the technology to make it easier for them to implement the process and train their people. So that's what gave birth to STPP, the Secure Technology Protection Program, and it had two phases. First was get secure, and the second is stay secure. So these are some of the elements of it. At the top of it, we provide free PSS support for any virus incident. There's a number to call, and that's in U.S. and Canada. That's kind of the baseline. The second thing is that MCS and PSS developed some assessment program offering. We spent a lot of time training people, bringing them in. In fact, we're bringing our people in again. In fact, it's tomorrow and Monday. We're bringing them, flying them in to do some more in-depth training on security in our current products, and then we're following up with security training on the .NET Server 2 days after that. There is a security toolkit. We put together a CD, which we made available to anybody, which had on it some resources around securing servers for server admins from small businesses up to large enterprises. But it was basically to help them bootstrap their process. And in fact, there's some tools on there. We have a patch distribution system that we're working on to augment Windows Update, but we bootstrap that by putting an auto update client or a bootstrap client. So once you install this, put the CD on, if you put the update client onto a Windows 2000 machine, then after that it would be able to receive updated versions of the client for auto update services downstream that I'll talk about in a minute. So it's a way you touch the machine once, and then you should be able to not have to touch it again after that. And then those things are available now. We actually shipped those CDs in November. And the last piece is that there are a number of different tools that we are building, and we will continue to deliver. One of them is the Microsoft Baseline Security Analyzer. Another one is a little piece of code for SMS that will enable you to roll out patches as we distribute them. And then lastly is this auto update client that I talked about. And the model is eventually that you should be able to just be able to have software updates flow out seamlessly to all the systems inside your network. So to drill down on the security toolkit just a little bit, it was fundamentally the goal of the tool set that we put on the CD and that we'll build and that we'll enhance going forward is to ensure that NT4 and 2000 systems can be brought to a secure baseline even when they're not on the network. There's a special setup wizard we put on the CD. You can actually kind of hit one button, and it'll go through and run a set of tools to figure out what the state of your machine is. It'll bring it up to date with the patches as of last October, that one button approach is primarily oriented towards small and medium businesses. It also has some scripts that you can use with SMS to do the same thing to a set of systems automatically. It included all the service packs and critical OS and IIS patches through October 15th. One of the things we've also done, well, I guess I'll talk about that in a minute, but we've also focused on making the patches themselves, identifying and delivering just the critical patches into special roll-up packs. HF NetCheck is a tool that you can run that will verify what the patch level is on your system. So you can see whether it's up to date or not. You can tell that tool was named by an engineer, but we went ahead and shipped it with that name anyway. That core technology is going into other tools we build. That tool also is extensible, by the way. It basically is driven by an XML file that tells it to look for certain file names, dates, and sizes. And you can extend that to do things that aren't even part of Windows, so that you can customize as a corporate or a consultant. You can customize the tool to verify the patch level or software level on a system that's got a number of different components. And then the IIS team developed a special lockdown tool because IIS is one of those services that has a number of different things. It's got an index server. It had mail server components and things. It had a lot of things turned on, fairly sophisticated configuration. So we built a tool to lock it down. It is locked down by default. Now you use the same tool to unlock it if you want to in the .NET server. But we built a tool to lock it down. And then URL scan is an ISAPI filter that will let you configure to filter out hostile URLs, attempts to poke at your system and penetrate it. So we're going to have a demo of the Baseline Security Analyzer. I'm going to have Michael Stevenson, who is the lead product manager in the Windows Server group, come up and do that.
Thanks, Dave.
Hi, Michael.
Let me get this on the screen here. There we go. So as Dave was talking about, one of the fundamental problems we discovered through the Code Red and the NIMDA process was that customers were having a hard time knowing which systems had security patches to them, which systems had been properly configured for security, which systems had applications on them that were misconfigured for security. So one of the tools that we're producing, and this tool will be available at the end of this month, is a tool called Microsoft Baseline Security Analyzer. And what this is designed to do, it's designed to do three things. It's designed to do, one, to ensure that common configuration settings in the operating system, both client and server, dating back to NT4, are properly configured. The second thing it's designed to do is do that same thing for both server and desktop applications. So on the server, things like IIS and SQL. On the desktop, applications such as Office and Outlook. And then third thing it does is it's able to scan either a single computer or multiple computers to identify which ones have been updated with the latest security patches. So let's take a quick look at the interface here. This is actually the graphical user interface. There's another interface through a command line, but for demo purposes, the graphical one always makes a better presentation. So there's a number of things you can do here. You can pick a computer to scan, or you can pick multiple computers to scan. And the nice thing about this tool is that you don't have to go out and load an agent on any of the machines. This you load on one machine in your environment, and it can go out to all the other machines without you having to physically touch those machines. So for this particular purpose, I'm just going to scan my local machine. So it gives the computer name up here, and then it gives you the options of the different things that you can search for. So for this particular thing, it's a client. I'll search for, check for hot fixes, check for weak passwords, and check the operating system for vulnerabilities. And we'll go ahead and run that scan. And this takes about a minute. What it's doing is going through and looking at the various user accounts that you have on the machine, looking at the policies that you have around those passwords. The passwords, the right length, have the right number of characters in it. Do they have to be renewed on a regular basis, and so forth. And then it also goes through and it understands what security patches have been applied and which ones haven't been applied. So what it does, it talks to a centralized service and gets an update. So if a security patch came out yesterday, this tool would know that it needs to look for that security patch across your organization. So while this thing wraps up really quickly, it's going to come up and it's going to give us a report. And if we click on this report, it brings up a pretty simple way to go up and take a quick glance and see what kind of vulnerabilities exist. So the first one, for instance, says password expiration, and it says there are 6 out of 6 user accounts with non-expiring passwords, which is not a good thing. I need to go fix that on my machine. So if you look here and you can actually click on result details, and this will tell you exactly what happened. These are the user accounts that I need to go look at and fix on this particular machine. The second thing, if I don't know how to do that, I could go to how to correct this, and it will give me a step-by-step guide on how to actually go out and correct this particular problem or vulnerability. Now as we scroll down to the vulnerabilities, we can look at OS hotfixes. So it looks like I don't have all the OS hotfixes I need. And I can click on result default details, and it will tell me that there's actually two of these. One of them was the IE patch, and the other one was the universal plug-and-play patch. And actually, if I go up and look at Windows Update, which I ran earlier, it tells me that I need to apply those 2 patches. So on a configuration like this, I can use this in conjunction with Windows Update to update those vulnerabilities. And what Dave was talking about is we're coming out with a corporate version of Windows Update. This tool will be a good tool to use with Corporate Update to go out and understand your environment from a baseline, and then use Corporate Update to actually apply those patches throughout your enterprise. Getting back to this really quick, there's some best practices here. So it noticed that I had some shares on here, and I can go on the results, and it will give me what should I be doing with those shares. Am I securing those shares properly? And in this case, I've done a pretty good job. And then vulnerabilities for the desktop application. So this was a desktop environment, and went in and told me that I've done a good job with Outlook, I've done a good job with macros, and that I've done a great job with my IE zones. But again, this is a tool that will be coming out at the end of this month. You'll be able to scan NT4 systems, Windows 2000 systems, Windows XP on the desktop, as well as Windows 2000 and Windows NT4 from a server perspective. Thank you.
Thanks, Mike. So I think the key thing here is this is just one more of the tools and things we will be developing and continue to release to the web and to complement the products we have to help customers run them securely. So the second phase, stay secure. One of the things that we figured out, we said, it's hard for people to figure out what patches they need. We didn't actually identify critical security fixes before explicitly. You know, there's the risk that if you do that, if another one that you don't say is critical turns out to be a problem, a major problem, then you know you feel like you're liable. You know what? The bottom line is nobody else is in a better position than we are to understand which vulnerabilities are important for all our customers to pick up. So we started identifying which ones we recommend as critical, and we'll bundle all those up into kind of a mini service pack that we do extensive testing on. It reduces the number of reboots involved and the number of different times that customers have to apply hot fixes. And so that's going to be an ongoing process. The first one we released in January, on January 30th, actually. In this spring, we'll get out Windows 2000 Service Pack 3, and that will have a number of these proactive fixes we found in running the new tools on critical components in the system, and as well feedback that we've gotten from this the security push we're doing on the .NET server right now, and also in the spring we're going to deliver a service that you can run to update. To effectively run your own Windows Update service inside an enterprise network, and I'll talk about that in a little more detail in a minute. And then the key point is that as time rolls on, we'll continue to deliver additional tools and enhancements and process around how to run our systems securely. There's an architectural guidance document coming out in April as well. That focuses on how to deploy all of our products securely. The Windows Update, we call it the Windows Update Corporate Edition. It may be called something else on the day it goes out, but fundamentally we're taking the Windows Update technology and delivering a service that you can run inside a corporate network. And it will deliver updates down to systems that have the auto update client. XP has the auto update client. Win2K can have this bootstrap client to pick up the auto update client that we talked about earlier. And then the administrator doesn't just roll out these patches. The administrator gets to selectively look at the content. They basically go up to the Microsoft Windows Update site and say, oh yeah, I want this, this, and this, pull it down, and then they can decide to roll that out to their machines. It performs basic logging of what was loaded and not loaded. It's got a simple web-based console. It's a lot like talking to Windows Update, only then extended to your corporate environment. And then another key thing is that it's basically infrastructure that's in the system, but it's not necessarily, as a piece of infrastructure, it hasn't got all the tools with it to necessarily selectively roll out and manage an update to a large number of systems. It's capable of doing that, but the tools, the way to do that will be the integration of it with enterprise management tools like SMS or other server management products that we have, or third-party products downstream. I mean, it's a piece of infrastructure that will be part of Windows that can be used by anybody. Could be scripted by corporate IT staff or by consultants. The auto update client, the other thing is that some of the control about whether or not a system is updated in the basic infrastructure is down in the client. It will auto install at a scheduled time. It will consolidate the reboots. It issues notifications to the user depending upon the mode it's in. You know, an update's here, do you want to install it? Or it can just force the update, which is an important feature for servers. It's managed by local configuration that's in the registry, but effectively is managed by group policy. So Windows 2000 with Active Directory you can use to both deploy auto update clients, but then also configure certain systems to have different update policies on them. So that's STPP. Then I think the encompassing view, in the end, the problem that we're all trying to solve, we've termed for us trustworthy computing. This is a thing that Bill wrote a paper on. Craig Mundy, who's one of our senior vice presidents of advanced technology, speaks on as well. and is basically a framework that we use to energize everybody at Microsoft and our customers around all the important elements of what's really a simple goal, and that is making computing, driving computing to the maturity that will make it just like electricity or water. It's just there. It just does what you want it to do. It doesn't do what you don't want it to do. Now, we know that the state of technology today and the sophistication of problems that people are trying to solve with it means that we're not there yet as an industry. But that's the vision. And it's broader than just, much broader than just security vulnerabilities. You can see it starts with availability, ensuring that the system operates at advertised levels of availability. Suitability, that it actually does what you want it to do. Integrity against data loss or destruction of data or alteration or somebody else seeing the data. Privacy, access to any user's data, corporate data or an end user's data, ensuring that it's authorized only as the way they want. On the internet, that's certainly one of the big challenges. Is you hand out lots of data to different sites as you use their services. That's very complex. With the .NET My Services, we have a framework where you'll be able to manage your data and give it out selectively as you wish, so you get convenience and privacy. But that's an example of a technology to focus on that. And then fundamentally, the way that people make decisions is not by evaluating every decision or every element of a product, but one of the overarching things they do is focus on the reputation of the system provider, the brand. And that's the goals are to drive on each of those dimensions. The means are a whole set of things around security and development practices, quality auditing, business practices in the way that you deploy it, and then policies around laws and regulations we can't forget. I mean, that's another element of this complex ecosystem that's evolving. Some of the virus attacks, there was a case recently where some fairly substantial damage was done, and the young man that did it got a number of weeks of community service as the sentence. And that's not going to cut it. The damage done by Code Red and NIMDA to businesses is probably measured in billions, and the person that did that, that started that, needs to be deterred from it with a little more than community service. And so, as an industry, we need to evolve the laws and policies to really adapt to the real world today. And I know that the governments around the world are on top of that, but that also takes time. And then all the elements of executing on that are key. But this is kind of the taxonomy, the way we view at a high level trustworthy computing. And what it takes in the short term, it takes improving designs, and we talked about the way we've trained our people to design and implement with the latest techniques the most secure systems. It takes policies in the way people run their networks and their systems, where they're serious about security, and that's the focus, as opposed to just making it easy or not focusing on it. And in the medium term, system management will actually be, and I think, as you can see from the focus on software distribution and configuration checking and things, system management is probably the key area where we'll need growth to make all this automatic and totally reliable over large numbers of diverse and distributed systems. And security in and of itself is really just a specialized form of system management. It's about limiting access and risk management. And then long term, we'll need to continue to evolve the way our systems work, do fundamental research about how you build systems where you don't have to work so hard to manage them and control access, that they just perform more in line with your intent. So the last thing I want to do then is within trustworthy computing, one of the things I think it's easy to lose sight of when we focus on vulnerabilities and viruses and stuff is that so we get all that out of the way. It turns out that 90% of the issues around security, the incidents that are security problems, that are violations of trustworthy computing, really have to do with people in maliciously accessing data that they're not supposed to, penetrating networks and things. And we have from day one in NT and then Windows focused on building an infrastructure that lets you do that. And a secure connected infrastructure is a theme I know you've heard a lot about this week in a lot more depth than I'll talk about. But I want to give you the top line view, because it is in the world of expanding connectivity, it's absolutely key to be able to, in a manageable, and that means integrated way, have a secure connected network, and Windows.net is the foundation for that. So, in fact, I talk about these in a slightly different order. Connectivity is kind of the thing you want, right? Your employees are mobile. They're mobile within your business. At Microsoft, we operate wireless. I operate wireless at home. I carry my laptop home with the same card I use here at work, and I just sit down and turn it on, and I have to manually establish a VPN, but then I'm connected back to work. And we use wireless all around here and throughout the campus, and that led us to the, understanding the latest phase or the latest sets of issues around a secure connected environment, because you know what? We found people sitting in the parking lots that didn't work for Microsoft listening to some of the wireless traffic around here in the early days. And so you've built this broad connectivity, super connected these days with you on the road, moving around the campus, in your office. And security obviously becomes very quickly the issue. Secure access to the network, protection of your data as it flows across the network, and then secure access to the resources, which has been an obvious problem from the beginning. The only thing that really makes it manageable, as I said before, is to make it integrated, because I'm one person in one entity, and what I really want is seamless access and protection to all the things that I want to access. And if that's not integrated, it's incredibly complex. So kind of touching on the challenges from the outside in, the network access service, you've got wireless, you've got VPN and firewall access, you've got regular LAN access, where we have LAN access, we also have outlets throughout this building, and 99% of the people that go through this building don't work for Microsoft. Now, we trust all you, okay, but on different occasions, sometimes people come in that might have less honorable intent. So in that environment, you've got all kinds of technologies to protect access to that with VPN and firewall. A user in a non-integrated environment can have a separate identity in all these different services, making it almost impossible to keep track of things. So how do I make sure in that environment that only the users I want get access to that environment? And in fact, I'd like that the infrastructure to be accessible to different levels of users. Okay, I'd like to ensure that others can connect to the internet but not connect to my network inside the same building, for example. So then I have to control access to the resources that are accessible by my network. And those resources, the different platforms, different applications may have multiple authentication mechanisms, authorization mechanisms. Applications will have their own little directories, sets of identities. Public key is the technology that we require. We require it for remote access at Microsoft now. We use smart cards to access remote access services. This is the card key that gets me in the building. Turns out to be a card that I pay for lunch with, too, interestingly enough. And then it's a smart card that I plug into my laptop when I'm on the road to access the Microsoft network. And PKI is challenging to deploy. And then, so how do I build this access that lets me sign on and access the network and all these core resources? Well, Windows.net is a platform that ties these things together. We use it at Microsoft. It's the thing that makes it provides the most integrated and easy to use platform for this. At the core is the directory, or the directory services, okay, not specifically one necessarily, but a set of services around that. And the Windows.NET Server family is the thing that provides VPN access. It has directory services in it, and then you can see another part of the Windows family, or the Microsoft family of products. We have a firewall product that also is integrated, the ISA, Internet Security and Acceleration Server. All those user databases are tied together for these resources and access points in Active Directory, and that's one of the things that makes it a lot easier to do this. It's a common store. It's not the only store, as you'll see in a second, but it's a common store that makes it easy to use this set of services. In fact, the firewall uses it to figure out who should have access. Our 802.1x service uses it with the public key infrastructure that I'll talk about in a minute, and it is the thing that gives us access to our resources. Public key, in the .NET Server, we made a number of enhancements, which I know were talked about, in our public key infrastructure and how to deploy that. And a simple comparison is when we started requiring these smart cards, public key access for remote access. You had to go get a certificate, and if you were on an XP service in a .NET served domain, which I was, we have an internal domain where we deploy early. It's called NTDev. If I was in that domain, it was transparent to me. I didn't have to do anything. Somebody gave me a card, and I was on the air. I was enrolled. And if I wasn't, if I was in a domain served by a Win2K domain, there were a set of things I had to do. Okay, I didn't have, I could do them fairly easily, but there was a set of steps I had to do to get the certificates into the machine to get off the ground. So we focus on making it easier and easier to tie together these key network and resource access mechanisms. And then lastly, there still will be other kinds of systems where the identities are stored and managed. And Active Directory, part of the directory family of products from Microsoft is MMS, the Microsoft Meta Directory Services, which is used to essentially manage coherently a set of resources in Active Directory, in multiple forests of Active Directory, in databases or other kinds of directories or directory-like information. The goal being at the end is simple: sign on once with the right credentials and get access to the network and all the resources. So I'll wrap it up just with what I call the pocket guide to Windows.NET security. You know, if you take away one thing, you carry this PowerPoint slide around in your wallet. We'll make sure you get small copies of it. But the bottom line is, this is what you should think, or I hope I've conveyed that you should think about Windows.NET security and what we tell our customers, what we think you should tell customers. Number one, Windows.NET will be the most secure Microsoft Server OS. I believe it'll be the most secure operating system in the industry. The things we're doing are unprecedented around our changes in engineering and use of advanced tools and techniques for building secure products, configuring by default securely, which will be an inconvenience for customers in the industry to get over in some cases. But on the other side of it, we can actually compute more securely than we ever could before. STPP around that over time will turn into this vision of organically flowing out Windows to Windows servers any of the updates you need if vulnerabilities are still found in the product, because there's some pretty advanced and aggressive thinking in hackers going on that pushes the technology forward. So you have to plan that there may be a vulnerability, and if there is, we'll have an infrastructure to let you roll out the fixes everywhere. And then, in fact, in terms of advanced technologies, managed code, which I didn't mention before this, but there were some talks in the .NET framework, are ways to write code that doesn't assume the full privilege of the user. So we've got coding techniques and tools and application framework that makes it easier to develop secure applications as well. So that's point number one. It's the most secure OS. Point number two, the integration simplifies security. Security is incredibly challenging in the connected world. Integration is the key. There's a unified directory and security infrastructure. We interoperate with other environments in every way we can. But when a technology, a general rule is when a technology has not advanced to the commodity stage, to where it's just like electricity out of the wall, that you have to, that integration turns out to be one of the key ways advances are made. And that's where we are. That's where we are today. So the unified directory and security infrastructure at the core. We have strong authentication via public key technologies and Kerberos, both based on widely accepted and mature standards, and a focus on single sign-on. So the client, you just log on once to the client, logs you onto the network, logs you onto the application. So that the summary is that then the Windows.net will be the best OS, the foundation for building those secure, connected IT environments. Because of that, the single model for authenticated network access, because of the integration with things beyond just the application platform and the server operating system, but with firewall products as well, not just our product, but others. And then lastly, as you open up the scope, with things like Passport, where there are other authentication entities or brokering entities that advances in .NET and beyond, a key focus is going to make that federated, because that single sign-on experience needs to be completely global, not just inside my company, but in the life that I live as a consumer, as an employee of a company, as a member of organizations, and as companies work together. So I'll end repeating the thing I started with, and that is that we are completely committed to do everything possible to help our customers compute securely, to work, communicate, transact their business over the internet in the global world today. So with that, I think I have about 15 minutes. Denise, I have 15 minutes for questions? All right, so I'd be happy to take some questions at this point. Yes?
All of the things that you mentioned in your speech are very exciting and I think very helpful. But in the meantime, my two greatest practical challenges are, number one, the Windows Update site isn't even trying to get the security updates any faster than 2 days after you officially announce them. And that just seems like a totally inadequate goal. And then two, almost all of your security patches require reboots.
Okay, so I'll repeat the question because we're taping this morning. Two things you said were that 2 days on Windows Update as a delay after the main site, right? Because the patches are up on the Microsoft site, but then 2 days later on the Windows Update site is too long. And then the second point was.
It's very hard for me to balance the desire to get patches applied as quickly as possible.
Oh, reboots. Right, I got it. Sorry. Right, and the second issue is that it's a real problem that patches require reboots. And the answer to both those questions is I agree with you. The Windows Update site, and it turns out for certain classes it sometimes takes longer than 2 days to get fixes onto Windows Update, and we are aggressively driving that time down. Okay, so Windows Update will be the core site for picking up updates. We got to fix that, and I will simply tell you that we are. We're working on driving that time down. On the issue of reboots, we have a number of things going on. You saw me talk about some things we're doing in the short term by combining patches and things to reduce the number of reboots. It turns out beyond the .NET server, there are changes we're making to some pieces of the system architecture. The ability, we're looking at the ability to actually change kernel code on the fly, but in other cases we're re-architecting pieces so that we reduce the number of times you reboot when you update code to an absolute minimum. Okay, there are times when you update the core of the trusting computing base that you need to ensure that you have a clean, non-spoofable restart. But that takes a fair amount of effort. So in the follow-on to the .NET Server, we expect to have eliminated every reboot possible. In the meantime, we're doing it in as many steps, or we're doing as much as we can in steps as fast as we can, because I understand that that's a big problem. Okay? Yes? So the question is, are we going to, or would we please extend our security initiative to outside? And the answer to that is yes, we are doing that, again, sort of practically as fast as we can. You know, we focused on training our internal people first. But this book, for example, the publishing of this book, Writing Secure Code, and Denise, we didn't happen to have the copies of that book here, did we, or not? Okay. What we should get the information about how to get the book, for sure. And I recommend you a copy of the book. It's a way to communicate the knowledge that we have developed. Some of the tools we have, like prefix and prefast, we'll look at ways to make those available outside. Right now, those tools are evolving and really built as internal tools. VC7 is a way that we take that out to our customers. Our prescriptive architectural guidance documents. I mean, we're looking at training classes and things like that. So this is a question that comes up every time we talk about this. And we're focusing on having the products at the core, the thing that only we can do and we have to do as quickly as possible. But then we will rapidly make that as broadly available as possible, because it's an industry-wide challenge. So, and you know, the .NET framework is an example of other ways we focused on being able to build secure apps. So, yep.
What's the expected release date for .NET Server?
Oh, there's the question of the day, right? Excuse me, I'll repeat the question. What's the expected release date for the .NET Server? And what I will tell you is that this security push, when we decided to do this, we knew that would impact the schedule, and we are going to let it. We're going to progress farther before we update what we give as a release date. I will tell you that I expect right now. We're actually focusing on two things, deployment and security push. In other words, we just internally built an update from Beta 3 called an IDS that we've rolled out in our IT department, and we're giving to our JDP customers, because deployment is a thing that takes a while, especially with infrastructure. So that goes on in parallel. The security push impacts the standard process of stabilization and fixing bugs. Because it adds more things that we'll fix. And I would guess that'll impact our schedule by a couple of months. But the bottom line is long around April, we will assess where we are and revise when we expect to deliver it. I won't give you a target date right now. The next key milestone would be RC1. And if the security push goes well, I could expect that, you know, in say 3 months or so, and then after that, it's a pretty standard, just fix the last few bugs, take any feedback process that we go through every time. So that's a long-winded answer to I don't know yet, but we're doing it the bottom line is we're doing it as fast as we can, but we will not ship a product that we don't believe is secure, and that's the way it is. Okay? Yes. Right. Your question is the thing that was demoed, the Microsoft Baseline Security Analyzer, who will that be available to? Okay, and the answer is it's going to go up on the web and be available to everybody. You know, I talked about some of the patch checking tools. You know, I'll go on a little bit of a leap of faith here. I think that uses the same technology for patch checking, for example. So it's extendable in ways. Partners can extend it to provide more comprehensive solutions, for instance, by updating that XML file. Because it's got HFNetCheck, that thing with a squirrely name, down inside as a core technology. So there are ways that partners can use it to do broader challenges, but it'll be up on the web. We're going to try to make this stuff available as widely and as quickly as we can. Yes? The question is, would I recommend to RDP customers and early adopters to wait for RC1? Well, I'll tell you what, we're not waiting for RC1. We're rolling out Beta 3. We're now rolling out this IDS build, which is not broadly available, but is an important measurement of progress along the way. So in general, I would recommend deploying as deeply and early as makes sense for your business, because the problem is if you wait, then neither you nor we learn early enough, oftentimes, to correct if it doesn't work out well. So, I'd be happy to talk to you for a couple of minutes about your specific situation after the meeting, if you want. I'll be outside for a few minutes. Another question? Yes.
Follow up on that question. The MSDN beta agreement that one gets with .NET Server Beta 3 anyway strictly prohibits one from using pre-release software in production. So as much as I would very much like to deploy in production, as I believe you just suggested,
Okay, so you said the MSDN beta agreement says don't deploy in production, okay? And that's in conflict with what I just said. What I was just referring to, we have special programs, okay, where we intentionally work with customers. The JDP program, that's why I said I need to talk to you about your specific situation, is in the JDP program, the commitment in that program, and these are for customers that are qualified, signed up, committed, and they invest alongside of us. For those customers, they make a commitment to deploy in production environments with our services. And by the way, I should be clear, deployment is an incredibly powerful tool for us in assessing the state of the product. But we always deploy first at Microsoft. We have about 100 directory servers, for example, rolled out .NET at Microsoft in our live day-to-day network. And before customers roll out, or JDP customers roll out in production, we expect to have all 250 that are in our primary domains upgraded as well. But so for customers in the program that I was talking about, they specifically do have to roll out in production. I was actually, to be honest, I was unaware that the MSDN beta said not to roll out in production. I don't recommend to anybody that's not in one of those programs to roll out in production, though it's certainly happened before. We've had customers approach us in sort of one-off situations and say, here's what we're doing, we'd like to do this. And in very special circumstances, we've said, okay, go ahead. And go ahead means we'll support you on doing that. But these other customers, right, we have programs in place to essentially give them special support during that process. Okay? So, in the back?
One of the industry analysts said that IIS was so compromised and without the technical support that Microsoft would have to rewrite IIS with a probability of 0.736. Would you like to comment on that?
Well, I should have had him in for a code review, I think. Actually, the question was this Gartner, is that who you said?
I didn't say it. I think it was that.
Yeah, so an analyst said that we had to rewrite IIS. It turns out we did rewrite IIS, but we started rewriting it a couple of years ago, which is, I guess maybe he thought that was a good idea. I don't know. I don't think it's the case that either IIS-5 or IIS-6 needs to be rewritten to be secure. The code needs to be reviewed, and the configuration needs to be defaulted appropriately. And those two things, basically, we have done those with a combination of the tools and the fixes we put out. IIS, because it was where some of these vulnerabilities were found, not because it's a particularly bad piece of code, but because it's the piece that's on the edge of the network and has a number of services. It got much deeper scrutiny earlier than some of the other components did. In fact, it set a model for some of the things we're doing for the system as a whole. So the things we're doing, we are reviewing and revising, implementation, fixing vulnerabilities we find and stuff. But we don't have to rewrite it to make it secure. It turns out we did rewrite it for other reasons because it's got better process isolation, reliability. In fact, there were talks this week on the re-architecture and gives better performance and things like that. It's a better app platform. Yes.
Some of the comments I get from a lot of our customers in reference to the whole issue of security and reliability is they have a perception that, I guess whether it's the marketing or the product groups, tend to treat server much like Office. How much features can we throw in, how quickly, how often? And even though we understand the need to keep ahead and abreast of the competition and feature functionality, I think that general approach of throwing in the sink and the kitchen and everything tends to destabilize the code base sometimes, as well as potentially create exposures from a security perspective.
Right. Okay. So the comment was that the impression is that we favor features over security and reliability.
No, the fact that so many new features come in so quickly, so rapidly, the code base is never really stable.
I see.
So
Okay.
when you compare it to a mid-range or mainframe system,
Sure.
the code base tends to be a lot more
Right.
stable.
Okay. Sorry. So to restate it, that because features are added at the rate they are, that the code has insufficient time to settle down and stabilize. Because it is common in the software industry that software gets better when you change it less and just fix some of the problems with it. Well, so a couple of things I'll say about that. I actually, in a sense, I'll respond to the way I restated your question first as well, because I think one of the things that is true is that we, as you know, in the same way we will not ship a product that we don't believe is secure. We will evaluate features very carefully going forward, and I think we will favor security over the addition of features as a general rule. We spend a lot of time stabilizing our systems, and we don't ship before we believe they're stable. Server products have a very long stabilization time, and so we, you know, compared to certain systems like mainframes, I think the evolution of our code is faster, certainly, but we do take a lot of time to stabilize it. We spend immense resources on trying to run long-haul tests in all kinds of scenarios and environments. But, you know, I think a very fair point. In fact, you know, Win2K, one of the reasons why the reliability went up a lot was because we focused in on driving the process to favor reliability over features. And the other thing is, in the bottom line, the Windows.NET Server, it has some key new characteristics. It's got the .NET framework, but around the infrastructure, for example, it's really a series of small improvements. It was much easier for us to deploy it live in our environment earlier because the amount of changes we were making in the .NET Server were much smaller than Windows 2000 relative to NT4, for example. So we actually got a slower rate of change, a focus on making the focus on features really is on making the current features more usable in almost all cases. But so I hope that answers that. Yes.
I'm confident that with the Windows security push, there will be a much stronger product, much more solid, less vulnerable product. But even so, it's likely that there will be vulnerabilities discovered after the product ships. Can you talk about who owns that responsibility and what the consequences are?
And this will be the last question I take based on time. The question is, who owns the issue of the fact there will be vulnerabilities there? In all likelihood, there'll be some vulnerabilities after we ship, no matter how hard we or anybody else tries to make their product secure. And as I mentioned in the talk, I mean, that's something you have to plan for. We actually, for our developers, part of this security push and training process is that we are putting in place that they personally are responsible for vulnerabilities in their code, as in it's tied into their performance reviews. That's one element of that. The Secure Windows team, as I said, is the team that manages vulnerability response, and so they are very expert and incented to manage the vulnerabilities down. And then lastly, we also, I didn't even mention this, but we're doing more end-to-end thinking as well, even around recovery processes and things. You know, if systems get damaged or destroyed, how can we help users bring back systems in a small number of minutes with the current user data? We've got some pretty advanced technologies that our research group was working on in that area as well. So we're thinking about every piece of this and planning for the realities. So with that, thanks a lot for your time, and it's time to move on to the next session.